my name is Derek from Tomcat Gas Training, and today's video is all about commissioning one of these. So what we're going to be doing is we're going to be going through the commission procedure outlined by the manufacturer Ariston for this Ecombi 1, and we're going to be looking at filling in the benchmark. Let's get on with it. Now, the first thing is always after the completion of the installation of a gas appliance, we need to carry out a tightness test first. So we did a tightness test before we did the installation. Now we need to do a tightness test after to prove we've left no leaks. So the first thing I'm going to do is I've isolated the gas supply. I'm now just going to remove the test nipple. Now, as always, on a tightness test, the first thing I'm going to do is a let by test to see whether a ECV is letting by. And you can do this between 7 and 10. And you can see I've done it at 9.37 millibars. So you have between 7 and 10 millibars for 1 minute. After a successful, you can see it's gone up by 0.04 millibars. So that's passed because we have 0.025 millibars. Next I'm going to do is temperature stabilization. And you can see I'm doing this at 20.15, so I have between 20 and 21 millibars to do this. And again, it's a 1 minute test. So we're just seeing whether or not it rises or falls, and it can do whatever it wants. It can rise or fall. So you can see now at the end of this stabilization period, it's just gone to 0.04. So again, we can now do a tightness test. So the tightness test, I'm doing it at 20.21. It's a 2 minute test. And at the end of this 2 minute test, it will tell me whether it's successful or not, and it's passed. Now, that's a successful tightness test completed. What it says for me to do now is I can create report. So let's create the report, print it off. We've got a copy to prove it's passed the tightness test. Now, after any successful tightness test, we now need to purge the system of air. So we need to get rid of this 5 to 15% gas in air so we don't get an explosion. So the only appliance we're looking at is this boiler. This is the only boiler, it's the only thing connected to this gas supply. We've no cooker to purge from, so we're going to have to purge from the boiler. So let's get purging. Now, if you want to know the full purge procedure and how to work out purge volumes, why don't you have a look at our video on purging on our channel. But you see, you need to open the windows, ventilate the room first. We need to take our first reading from the gas meter, so you can see it's 0.55, nearly, well, halfway between the 0 and the 1. So we need to go to the underneath the boiler now onto the gas connection and just undo the nut at the back of the gas supply, and we need to purge this minimum volume of 0.01 meters cubed or 10 decimeters cubed. So once we've done that, you can see the final reading now is 0.56, just over the 2, so that's the 0.01 meters cubed or the 10 decimeters cubed. So we're just going to re-tighten up the nut now. We've passed that minimum volume. Make sure we tighten it up correctly. I couldn't have picked one of the worst boilers in the world for trying to tighten up underneath, but there you go. But after we've purged, because we're not going to be doing another tightness test, we need to make sure we spray the joint with leak detection fluid, LDF, and wait for at least 15-20 seconds before we wipe the excess off. After a successful tightness test, we've purged. After a successful purge, we can now take our standing pressure. So I've still got my little SP620 still connected. So that's still here. I can now take my standing pressure, and at the moment my standing pressure is reading 26.5. So 26.50 millibars. So that's what my standing pressure is reading. So after I've done my standing pressure, I can now do my working pressure at the meter. So let's get on with that. Now, to get the working pressure for this boiler, I've still got it connected to the app. All I need to do is turn my tap on maximum. Now, some guys do their working pressure at the meter in maximum setting, but I've set my boiler on hot water to the maximum. I've opened the tap to give me a full flow rate, and I know this boiler will go on to full rate by doing this. And at the moment, my working pressure at the meter is 21.27. So that is our working pressure at the meter. And what we're looking for is a working pressure at the meter of 21 millibars plus or minus 2 millibars to show us that we've got enough gas coming in and the regulator's working correctly. So, working pressure at the meter, very important. Now we've finished with the manometer at the actual gas meter, we can now put the test nipple back. We can now tighten it up, but remember, don't over tighten it guys, you can split the barrel of the test nipple. And then, because we've not able to test this, we need to now test it with leak detection fluid. No, I never turned the gas off all the time I was doing this, so I never allowed air back into the system. And after we've used our leak detection fluid, we can now wipe off the excess after 15-20 seconds to make sure we don't leave it to corrode the meter. Great. Now, while we're at the tap, there's a few tests we can do now before we move on to the boiler itself. First of all, for the benchmark book, we need to know what our hot water temperature is, what our flow rate of our hot water is, and what our incoming water supply is, so we can work out the delta T. I'll explain the delta T on the board now. Basically, what delta T is the difference between the hot and the cold water. Our delta T, if cold water is 10 degrees C and our hot water is 50 degrees C, then our delta T would be 40 degrees C, because 50 minus 10 is 40 degrees centigrade. So basically, that is, in a nutshell, delta T, the difference between the two temperatures. You can also get delta T in central heating. That would be the radiator temperature, the water inside the radiator, to the air temperature in the room. That's another delta T. So delta T, in a nutshell, the difference between the temperatures of two things. We're back at the tap. So what we need to do now is, first of all, I need to get my cold water temperature. So I'm just going to turn the tap onto the cold. I'm going to open the tap now onto its full rate. Doesn't really have to be on full rate, I just need to get it to run a little bit to be cold. And now, using my thermometer, I can now take my cold water temperature and see what it comes out at. Now normally what I would do is, I'll try and see if you can see this. I get my weir cup and I place it in the bottom of the weir cup like that, and then take the temperature. So we need to leave it for a few minutes, a few seconds, to make sure it gets an accurate reading of our incoming cold supply. And it's really important that we do have the incoming supply cold temperature. So I'm getting a stable reading of 10.2 degrees centigrade. So that's my incoming cold water temperature, 10.2 degrees C. Now, according to the manufacturer of this boiler, Ariston, it says the 24 kilowatt boiler at 12.1 litres a minute at a delta T of 30 degrees, that's what we're looking for. For a 30 kilowatt at 30 degree delta T, or a 30 degree rise, we're looking at 14.5 litres a minute. Now if we go to 35 degree rise, that drops the 24 kilowatt down to 10.4 litres a minute, and the 30 down to 12.5 litres a minute. So it depends on how quick you open the tap. So to test that, what we're going to do is, on the 24 kilowatt, because this boiler's a 24 kilowatt, we're going to set our tap flow temperature so around about 10.4 litres a minute, and see what hot water temperature we get coming out of this tap. And if we get round about this 35-degree rise, then happy days. If we get more than the 35-degree rise, even better. But if we get less than 35-degree rise, then we could have an issue. So let's try that now. So I've set the wake up on to, well, the tap's flowing round about 10 litres. Just open it up a little bit more. So it's flowing around about 10 litres a minute now on the wake up. I can now take the thermometer and I can place it in the bottom, and I now need to leave it to stabilise and give me a stable temperature reading. Now, convict boilers shouldn't let their water go above 60 degrees, and if the water does come out of this tap higher than 60 degrees, then the boiler should be knocking off. But it should modulate the boiler too, also to keep it between 50 and 55 degrees coming out the tap, or whatever the delta T is. I've got now a temperature of coming up to 40 degrees. Remember, according to the building regulations, they reckon 38 degrees is good enough to have a bath. And they were supposed to be changing it at taps as well, which hasn't come out yet. We'll see what happens in April. This is trying to keep steady now at 40 degrees, and now 40.3 degrees. So this boiler is giving me a hot water temperature at flow rate of 10.5 litres, around about 10.5 litres at 40.3 degrees C. So if we look at our delta T from this tap, our cold was 10.2, our hot was 40.3, so 40.3 minus 10.2 is 30.1. So that is our delta T for this tap and this boiler. Now, next test I'm going to do now is our inlet pressures. So I'm just going to undo the inlet test point on this boiler, which is down at the bottom here. Okay, so I can hear the gas coming out, and I'm just going to put it onto the test nipple. Okay, I can get this out of the way now. I'm just going to stick it on the side of the boiler. So it's saying giving our standing pressure now of 25.4. In the benchmark book, it says working pressure at the appliance in hot water and heating, not high and low. High and low setting is for flue gas analysing. So some guys do it on high and low, but the benchmark book's asking for it on hot water and heating, so what it's actually getting. Other boilers have a test point actually at the boiler, so where it comes in, at the gas isolation valve. And we should have no more than a 1 millibar difference between our working pressure at the meter and working pressure at the appliance. Now, Ariston don't give us that inlet test point, but what they do say is at the gas valve, in hot water and heating, it cannot go lower than 17.5 millibars. And that's from the manufacturers, and that's in the manufacturer's manual as well. So what we're going to do is, first of all, I'm going to put it on hot water, so I'm going to turn the tap on. You can hear I've got the hot tap running, and this boiler is now got an inlet pressure of 20.43. Okay, so round about there, so it's going between 4.3, 4.5, 4.6. So that is our working pressure at the gas valve on hot water with the tap running at maximum. Let's try the central heating. Now you can hear the boiler's now in central heating mode, so it's not running at full pelt, it's running at maximum for the heating for what it needs. So it is giving me an inlet working pressure of 22.2936, so it's slowly modulating around as it's going around. So that would be our inlet working pressure. Remember, it can go down to 17.5, what it's saying in the manufacturers. We're well in because we've got 22.41 now, 42, something like that. So that is the working pressure at the gas valve with the central heating on. And both hot water and central heating, I put them on to maximum on the temperature setting on the front of the boiler. So this is what its maximum would be. And don't forget, once you've finished, remove your test hose, tighten back up your test nipple. Don't go too tight, you don't want to be snapping it. And then make sure you spray with LDF to see whether your test nipple is leaking or not. Obviously it'll bubble up. And then don't forget to wipe off the excess LDF with a clean cloth. Trying to get all the excess off what's been left from by trainees. Next test we're going to do is, we're back at the meter. So we're going to be gas rating. We're going to gas rate on hot water and central heating. Central heating is going to be on maximum, hot water is going to be on maximum. Now if you want to see a more full in-depth video on gas rating, go onto our channel and have a look at that. It gas rates with a U6 and a G4 and all the other smart meters. We've got a G4 meter, so let's quickly go through that. First thing I'm going to do is turn the tap on, because we're going to gas rate hot water first. So that's the first thing. The next thing is, I'm going to wait till I get to a full figure before I start the stopwatch. And now I'm going to wait 2 minutes and take my second reading. So we're coming up to our 2 minutes. And let's take our second reading. Let's gas rate central heating. Now, what you don't want to be doing on your central heating is start gas rating as soon as you turn that boiler on, because that will just give you your maximum on central heating load. You need the boiler to work a little bit to give you your actual load for the heating. You need to run it for about 5 minutes before you start doing your gas rating, just to give that boiler enough time to go, oh right, okay, this is what I can do, but I only need to do this. And that gives you some idea, so if you wanted to range rate the boiler, you could do. So again, first thing we're going to do is wait till we get a full figure, start the stopwatch, time for 2 minutes, take our second figure, and then let's go and do the maths. Now again, I'm going to wait till it gets to a full figure before I start the stopwatch. So all we're going to do now is wait for another 2 minutes and then take our second reading. Now we're coming up to our 2 minutes. There's our second reading. So let's go and do the maths again. Now let's look at the maths from the gas rate. So we'll start with the hot water. Our first reading was 0.030 and our second reading was 0.115. You take the 115 or the 030 away from each other, you get 0.085, but that's meters cubed for 2 minutes. So we need to give us times it by 30 to give us the meters cubed an hour. So we got 2.55 meters cubed an hour, which equals 27.41 kilowatts gross, or 24.69 kilowatts net. So we need to look at the manufacturer's instructions to see whether that's correct or not. Look at the central heating. First reading was 0.200. Second reading was 0.235. Take one from the other, you get 0.035. Times that by 30 gives you 1.05 meters cubed an hour, which gives us 11.28 kilowatts gross and 10.16 kilowatts net. We can now check with the manufacturer's instructions to see whether our gas rate is correct and what we're looking for. Now, next test. I've got the DC 710 with my K-probes for doing the temperature. So this is our flow pipe, this is our return pipe. I've got them clamped as close as I can get them to the boiler. Now the boiler's been running for at least 10-15 minutes now, and you can see that by the temperature, because our flow temperature is 72.4 and our return temperature is 61.9, so we've got a temperature difference of 10.7. Now the things with the temperatures, we don't want less than 10 degrees and we don't want more than 20 degrees for a condensing boiler. Well, less than 10 degrees coming back to the boiler, then you've got it whipping round something really quick and it's not going to be in condensing mode. The other thing as well is if the return temperature is over 55 degrees, it won't be in condensing mode anyway. And the boiler should always try and get into the return temperature of being less than 55 degrees. Weather comp helps this massively, stopping the boiler going up into temperature too quickly. This hasn't got weather comp on it, in fact it's got no controls on it at the moment, but we'll talk about controls when we get there. So at the moment we've got 74 on the flow, 63.3 on the return with a 10.6 degree temperature difference. So we would putting that on our flow and return temperatures. I always wait till we try and get to the maximum flow temperature for this boiler to make sure we've got this no less than 10 and no more than 20. This is only on a very, very small system. There's only 4 radiators being fed from this boiler, and they're only very small anyway. This is why we've got this only a 10 degree difference. If it were on a bigger system, it would be a different story. So that's taking the flow and return temperatures because I'm just waffling now. Now, while I'm down here, I might as well check the flame rectification on this boiler, so the flame supervision device. So as you can see in here, the boiler is running on central heating. So what I'm going to do now is I'm just going to turn off the gas supply, and what the boiler should do is the boiler should go into lockout. So let's have a go. So it's saying SP3 on the front. It's trying to ignite. So that was the first attempt. It's now saying SP1. And it's trying to ignite. So that's the second attempt. It's now saying SP2. And it's trying to light again. It's now saying reset 501. Okay, so it locked out after its third attempt. So what I need to do now is turn the gas supply back on, press and hold the reset button, and it's now back on. So let's see if it lights up. And away it goes. So that's checking flame rectification or the flame supervision device for this condensing combi boiler. Benchmark now says about balancing radiators. You'll see loads of guys will say on the internet, oh, you start at the closest radiator to the boiler and you screw it all the way down and then you turn it back one turn and then you go to the next radiator in the line, turn it all the way down and turn it back two and go along the system like that. But the best way of doing it is by actually setting the valves up by using your analyzer or a thermometer to make sure you've got about 10 degrees. Now I've got a flow on this here of 61.8 and I've got a return of 51.9. At the moment I've got a 9.9 degree difference. I've set this radiator up to have a 10 degree difference across the flow and return. If it's now 10.1, look. So at the moment I have got a flow temperature of 61.9, I've got a return temperature of 52, so I've got 9.9 degrees C difference. So if I wanted to adjust that, what I would have to do is take the lock shield side off, get my spanner and screw it down to reduce the flow rate going through the radiator so more heat is coming out through the radiator. The faster you have the water going through the radiator, the less heat what's going to come out of that radiator and the equal temperatures are going to come across the pipework. So you don't adjust the thermostatic side, it's always the lock shield side, and then make sure you put the screw back in so the customer can't play with them, and that's how you balance a radiator correctly. Let's talk about condensate dispersal. So the condensate drain. This is where we've had some big changes over the last year or so. Basically, the benchmark doesn't want us to be running condensate pipes outside because of freezing. And if we do run them outside, then we have to follow the manufacturer's instructions and the building regulations. and basically we need to insulate the condensate pipe going outside there, and it can only be 32 mil as a minimum. It can be bigger, but it can only be a minimum of 32 mil, so we're not running overflow pipe outside now. So we need to run it internally wherever we can, and it says only run it externally if it's impractical to run it internally. So we've got two different ways of doing it here, so we'll have a look at this first. Now this has got the pressure relief and the condensate going into an internal trap, an internal waste pipe. So this is on push fit because it's got the blow off going into there, but the blow off has got a ton dish there, so it's an air brake, and you can see it actually would be running through there. So if it was dispersing the water, you would see it. And then this condensate line's going into the same pipe. Is it legal or is it not legal? Well, it'd be better if they were run separately, like this one is. So the way this one's run is, again, it comes down into the waste pipe, again it's into push fit, but this time we're using what's called a Tesla trap. So this Tesla trap, it's not made by the car manufacturers, it's Tesla UK, you make cook hoses and stuff like that. So what they do is, it's got a non-return valve in it. So this could be connected to a soil stack, and you won't get any smells coming back. But one of the biggest problems we have is some manufacturers say they want an air brake in this pipe. So if you do connect it to a soil stack, are you going to do that then? Anyway, follow the manufacturer's instructions on the boilers for all the condensate dispersal and obviously the building regulations. But according to the benchmark book now, it says don't run it out externally unless there's no other option of running it internally. But if you do, we must insulate it. Loads of different manufacturers out there now can help us with this situation. Now, next thing is flue gas analyzer. So we're going to analyse this boiler. So we're going to do maximum, minimum, and we're also going to do our flue integrity test. So first thing you need to do is remove the test point on the top of the boiler. The next thing you need to do is set the depth gauge for the analyzer, about 150 mil. If you want to see how I fully go through flue gas analysing and how to understand the results, I've done a series of videos on using flue gas analyzers, understanding the results, so check them out. So the first thing I'm going to do is minimum, because if I put it on maximum first, it'll heat up the heating too quick because there's only a few rads and I won't be able to do my minimum test. So I'm going to do minimum first, then I'm going to do maximum. Anyway, stop waffling and just get on with it. So, in we go. And I need to put this boiler now into minimum setting. So I'll go down to the bottom, press the reset button and hold it in till it comes up with test. Then I need to press the minimum button till it comes up with the tap and the central heating, and that will now put me in minimum test mode. Okay, so I've started the pump on the analyzer via my app. It's now running through. Now remember, we have to give this at least 10 seconds to come through for its reading. Now this boiler's been running for quite a while anyway, so again on my video you'll see it's a minimum of 50, maximum of 30 on the time wise until you get a stable reading. So at the moment we have a carbon monoxide of 0, a carbon dioxide of 8.5, a ratio of 0, oxygen of 6%, excessive air 39%, with a flue temperature of 70 degrees. So that's pretty much what I've got for minimum. So seem to have got a stable reading. What I'm going to do now is I'm going to put it in maximum. So to put it in maximum mode, I need to press the plus button until just the tap comes on. And this now should send it into maximum mode for me. And because my system is so small, it's locking out on maximum mode straight away. So I've had to open the tap so I can get rid of some heat out of the heat exchanger to allow it to go into maximum mode, because there's only 4 rats on this system. At the moment I've got a CO of 61, gone up to 62 now, carbon dioxide of 8.6, a ratio of 0.0007, oxygen of 5.7, excessive air 38%, temperature 61.9. So that's basically what we're getting. You shouldn't have to alter this on a brand new boiler, so just be aware, guys. Don't start adjusting them just for the fun of it. Okay? Watch my video, explains it a lot more. So that's flue gas analysing, what we need to do. Let's have a look at flue integrity. First thing I need to do is change the probe over. So I need to adjust the stop and slide it into the boiler. I've left it on maximum because I'm in that setting now. And see what we get. And what we're looking for is an oxygen reading of more than 20.6 with CO2 of less than 0.2 with no ratio. So at the moment I've got 0 ppm on carbon monoxide, I've got 0.2 on carbon dioxide, I've got an oxygen reading of 20.6. Okay, so that's on maximum. Let's put it on minimum. So on minimum I've got carbon monoxide 0, carbon dioxide 0, no ratio, an oxygen level of 20.9. So that's our flue integrity. Now, according to the standards, every boiler now has to have some kind of magnetic filter fitted to it. It also needs to be, during the commissioning process, be completely cleaned. So this can either be done with chemicals, or it can be done with a power flush, or it can be done with a magna cleanse, or a mixture of all of them. And after you've cleaned the system, you must make sure you put inhibitor into the system to inhibit corrosion. 2 dissimilar metals in the system will create electrolysis, it will create corrosion. Also, if you're getting air dragged into the system, that will also create corrosion. So we need to inhibit the corrosion by installing this stuff, and this will need to be checked annually on the service as well. Magnetic filters are coming incredibly important now, and the regulations are now saying we should be installing these. Loads of different filters on the market at the moment. Some manufacturers even put their names on filters and give you a higher warranty. So whichever boiler you're fitting, fit the correct filter for that boiler. Now let's have a really quick look at controls, because this video is just going on. Right, first thing is, because of Boiler Plus, we have to make sure that our stat is Boiler Plus compatible. Because every combi boiler, so we've been looking at combi boiler, needs a room start and it needs a time clock. So however you do that, whichever way you want to do it. But I would always advise use the manufacturer's controls, because they will make the boiler work at its optimum. So the 2 boilers I've got to the behind me and the side of me, one's working off an internet control. So this is the internet control here. The other one is working off this room start, so it's got an RF room start, but it's got weather compensation. So we've got pretty much everything set up here for Ariston training, so whatever they want to do with the boilers. So always fit controls to Boiler Plus, and always try and fit the manufacturer's controls, because it'll make it so much easier for installing, and it'll make the boiler work a lot better. Now that is the full commissioning procedure according to the manufacturer's instructions and the benchmark scheme. Now that is the end of this video on commissioning a boiler and filling in the benchmark. So if you've enjoyed these videos, why don't you give us a thumbs up or leave a constructive comment down below. If you're not subscribed to our channel, then get subscribing, and don't forget to hit that notification bell, because we release videos every Wednesday. All I've got left to say is thanks for listening, thanks for watching, cheers guys.